Good morning, everybody. My name is John Sabo. I guess it's time to start. It's half past the hour. I appreciate your coming out today. This particular talk was scheduled fairly recently. OASIS Open, which is the standards development organization that I'm a member of, has a working agreement with Identiverse. And so they gave us a speaking slot at the last minute. And I appreciate your coming because it's an unusual topic. I'm going to talk a lot about the intersection of some concepts and then give you some specific examples of both open source projects underway at OASIS Open and standards development at OASIS that are relevant to that broader topic of privacy and security engineering. And I'm a distinguished contributor to OASIS. I was a member for a while and someone nominated me and they made me a distinguished contributor. There are a couple other distinguished contributors from OASIS at the conference this week. Drummond Reed has a talk today at 5 o'clock. He is working on the sovereign identity space. He works for Avast and I've worked with him for many years. And other collaborators here in the audience I've known for many, many years. As you can tell, I'm ancient. I started when we used to take computer jobs down to the computer room and punch cards, and then our researchers would go down at the end of the day or the next day to get the printouts, and that's how we worked. And now we're in the world of interconnected systems, and that's the point of the title, the Tapestry of Technologies. I tried to be alliterative to make it interesting, and at least about 40 or so of you found it interesting enough to come. But how do you manage identity, security, and privacy risks in today's environment? And I'm going to talk a little bit about that for the last, since I retired formally from Computer Associates CA Technologies. And before that I was with IBM, and before that I worked for the Social Security Administration, and my team set up the first agency website in the early days of the web back in the 1990s, and that's how I got into security from a technical point of view, although I'm a policy wonk. One thing I'll say is in the presentation there are a number of acronyms, and I hope your hands don't go up to ask me to explain what each one of those means, but you all have search engines, and I tried to bone up on the acronyms, but it became very daunting to kind of deal with them. So trust me, if you want to deep dive into any of these standards or technologies, just do a search and you'll find it. Another operational point for the conference is they're not posting the presentations, I was told this morning. So if you would like a copy of this presentation, we will post it on the OASIS website and or send me an email. My email address is at the end, and I can get that information to you. So with that, let me move forward to the talk. The agenda. I want to give you a little overview of OASIS because it's a great standards development organization. Talking about the difference between standards development and open source projects. And I have some specific examples of cybersecurity related, which touch on identity, QR code standardization, which is a new technical committee in OASIS that's just published a specification. And I know we have at least one representative from one of the sponsoring companies here in the Trusona, and I think Boyan Simic from Hyper should be here, but I haven't seen him yet. I'll talk about privacy and the work we've done with our privacy specification and how I'm taking that to ISO, where I'm co-editor of the ISO version of that standard. And then I talk about future work that could be done through collaboration. OASIS itself has been around for a long time. It's an open standards development organization. We have members who are either corporate members, individual experts from companies who join OASIS, or in my case, as an individual member, I'm not affiliated with a company any longer. 2,000 participants, 70 communities, and over 150 standards have been published over the many years of OASIS. The process is very open. You establish your intellectual property mode so that the organizers create a charter, and you can, for the standards project, as well as for the open source. You create a charter, you set up your rules of engagement, everybody operates under the same IPR restrictions and or rights and so on. And as an example, they even have a non-assert IP policy that you can select, which we did for our privacy management standard, which means the contributions are without any royalties or constraints attached to the use. So for some of the OASIS standards, there is no, like the PMRM, which is our privacy specification, there are no costs or royalties or anything attached to the use. All OASIS asks for those is that you give OASIS credit for the basis for the standard. So you can build a product on top of these standards, and as long as either you abide by the IP restrictions, if there are any, or if it's a non-assert, you can basically make use of it as long as you credit OASIS. So members set up a charter, they set up the goals and so on, and then OASIS provides the background to manage that. So a lot of standards have been developed and are maintained by OASIS, SAML, which you're familiar with, and some of the newer ones related to cybersecurity that I will talk about. Companies, industries, a lot of members of OASIS, you'll identify the logos here. And let me talk about how it works, and I'm not going to dwell too much on this because I want to move into some of the standards, but we have a technical committee process, which I'm more familiar with because I helped organize a couple of technical committees, an open projects process. OASIS also provides technical advisory services and or affiliation with organizations, de jure standards organizations such as ISO or ITUT, and Foundation as a Service, where OASIS will host an entity that wants to set up its own kind of standards development or other nonprofit organization utilizing the OASIS infrastructure. A big thing that's important, and you'll see this in a number of the examples I provide today. There's this tension of sorts and yet synthesis and symmetry between open source project development, writing code through the open source project using GitHub or whatever mechanism that is usable, and OASIS supports that. By the way, if I fall off the platform, it's because the lights, I guess they're videotaping this, and all I see are dots floating everywhere, but I'm sorry. So open source is a great opportunity to have collaboration within a structure. Open standards take longer because in the standards development process, it's not like it's more of the traditional waterfall software development processes where you do this and then you do this and then you do this. It's more agile in the open source community. So there is strong IP management, use case definition up front, and a formal consensus approach in the standards development process. So it takes longer, and a lot of the criticism is, why should it take 18 months, 2 years, whatever, to develop a standard? I think a lot depends on the composition of the team, and the ESAT technical committee that I'll talk about in a few minutes moved fairly quickly because it had the contribution of work from members, Trusona and Hyper, to jumpstart that standards development process. If you start from scratch, it's going to take longer. The open source project also has a IP governance process. So the open source projects, it's an iterative development, it's more consensus based. But the important thing is both exist together. And Richard Strauss, who is one of the founding members of the CTI, Cyber Threat Information Technical Committee, has a very good video on the OASIS open website, YouTube channel, and Cybersecurity Alliance website about that integration of both a standard with the code development side of the house, where you can actually begin to show implementation of the standard. And OASIS does both. And I think the two need to coexist. You need to have the thought process and the structure in many cases, but sometimes that's very intellectual. And as you'll see when you move to implementation, you need the code. You need to integrate solutions. So it's interesting. In OASIS, there's a common governance model. And the TC, it's open to any organization. It's a lightweight process, unlike the international standards organizations such as ISO, IEC, and ITU, and so on. You're not organized around national bodies where the United States has ANSI, and the British have their own national body, and the India has its own, and so on and so forth, China. You're really working with individuals who are representing companies or as individual experts. So it's a more lightweight process. All the work of the TCs is publicly accessible, meeting minutes and so on. It's published on the OASIS website. So it's not like done in, I won't say secret, but in the ISO process that I'm working with now, we are not allowed to share or draft committee drafts or working drafts outside the working group. Even going across working groups in ISO, it's a pain, it's difficult and challenging to get access to other standards development underway. You've got to organize that, and it's been my experience. It's a part of the culture of the international standards development process. But there are advantages and disadvantages to that. OASIS is a little bit more democratic. All TC members have the same rights. Everything is very visible, and then proposers choose the IP mode. The open projects approach is there's a vetted IP process, open source licenses. They use, I believe, GitHub to do the actual code development and integration. There's someone who manages that for the project. And they can also submit work to ITU and to ISO and so on via PAS submitter status. So that PAS, PAS is another acronym. That one I remember, publicly available specification, which means that OASIS has the ability to go to ISO and propose that a particular standard or open source project be accepted as a publicly available specification without going through the complete ISO process. So let's focus a little bit on open source projects. There's a number of them underway in OASIS. The one I'm going to focus on a little bit more specifically is the Open Cybersecurity Alliance. I have not been a part of that project, but I'm aware of it, and I'm going to show you some of the work that they're doing, as well as the standard side of the work that they're doing, which is the Cyber Threat Information, CTI Technical Committee, which is also an OASIS. And Cybersecurity Alliance actually has its own, I think it's cybersecurityalliance.org. They have their own website and they have a lot of content. And it's an interesting use of, it's an interesting integration of the security professional world, identity, data protection world, technical and policy, working together in a collaborative mode. So the project itself, again, it's an open project in OASIS. They develop sets of open source code, patterns, practices. I believe the intent of this is an integrated cybersecurity capacity instead of silos. And when I worked maybe 10 years ago, 8 or 9 years ago on cybersecurity, everything was siloed, and vendors in particular were hesitant to share information across their silos, security vendors, because they were basically compromising the first priority was their customer base, second priority was the sharing side. I think I'm not active in this now, but I sense, as you'll see the projects I'm going to describe, or at least walk through for you, they've moved beyond that. And the US government, the new executive order about a year ago, basically mandated that the US government take steps to basically have an integrated approach to cybersecurity and move beyond the silos from the government perspective, and I see that happening in the industry. So the idea is integrate once and reuse. Make it simple to do all of the cybersecurity things you need, whether it's looking at the compromises or attacks against identity systems or anything. You have a way to communicate, to discover, to share, and to mitigate. And so that means operating seamlessly, and that's a daunting task, but they are developing a lot of, they have a lot of initiatives that are working on this. these, some of these, like STIX Shifter, are based on the standards that have been developed in the technical committee side. STIX is Security Threat Information Expression. It's a data, it's basically dealing with the data itself, nomenclature and organization of the data. And TAXII is an automated exchange of intelligence information. So TAXII is dealing with the transport of that, and these standards work together. So STIX Shifter is a tool chain for a unified query and response system using these standards that I've talked about. PACE, Posture, Attribution, Collection, and Enumeration, basically allowing you to search your architecture, determine whether or not you are systemically prepared for cybersecurity attacks, whatever, and so on. The Kestrel threat hunting language, I had to do some research on that. It's a unified language to search for threats across all your data sources. Indicators of behavior sharing, again, indicators of behavior where as you identify behavioral anomalies in the network or in the area you're examining, you can actually pull this together and do analysis. Ontology, dealing with the integration of information to have encoding, to look at the whole data fabric, not just the endpoints in a particular enterprise, but the whole fabric. So it's very ambitious. And zero trust architecture, I think that may have been contributed by IBM to the initiatives, but it's creating, looking at zero trust. All the elements that constitute trust in an architecture is examined through this. So they're putting these together, and when I talked about engineering, this is exactly, this is an example of how in this space, this open project, OCA, Open Cybersecurity Alliance, is doing what you should be doing today. If you go to any of the talks today, there's incredible work going on in this conference, and it's going to be talked about in a lot of sessions. You're looking at identity, you're looking at OpenID, all this is going on. Now, how do you integrate this in an actual implementation? How do you deal with it in terms of your cybersecurity policies? How do you deal with it in terms of privacy management and security management in an integrated fashion? So this attempt by OCA is to thread together basically a tapestry of integrated code, integrated capabilities that can be used. The technical committee side in cybersecurity, again, lots of acronyms. I think this is probably because a lot of the impetus for these cybersecurity standards came from the government, and having worked in the US government, everything has an acronym, which unfortunately or fortunately is life. So these are some of the acronyms, but there's collaborative automated course of action operations, Common Security Advisory Framework for standardizing the disclosures of vulnerabilities, et cetera. STIX and TAXII, which I've mentioned. OpenC2 is standard language for command and control. SARIF, static analysis of results, interchange format, standard output for analysis tools, and threat actor context, semantic interoperability for threat actors. And if you go to the website for cybersecurityalliance.org and or OASIS, you'll see, and the OASIS OASIS-Open YouTube channel, you'll be able to see videos which talk about these in much more detail, and you can drill down very deeply. But it's really interesting to see how they're working to take these standards and more, integrate them into the open source project for code development and for the actual tool development. The recent momentum, the executive order that I mentioned, which came about a year ago, roughly in 2021, which highlights VEX, which is the Vulnerability Exchange Profile. Basically, it's been implemented in the Common Security Advisory Framework. STIX and TAXII are standards, et cetera. There's a self-certification program coming, and there's a collaborative automated course of action playbook now available for public review. So it's interesting to see this happening. And one of my pitches to you today is if your company is not involved, this is cybersecurity focused, but there's a place for identity here, and there's a place for components. If your company is not involved, it's something to think about because it would help your company as you integrate your products and your proposed solutions into a bigger framework. But that's been my experience in any event. So let's talk about, it hasn't visibility here. Looks like the slides have failed. Actually, I feel like, I won't say like Captain Smith and the Titanic, you sail on your maiden voyage, so it's the opening event at this conference, the first day. Not all the systems are working, at least we haven't lost the panel yet. And I don't have my lookouts, I don't have any way to see ahead, I don't have enough lifeboats and all, but here I am. So you can see all the standards that on the screen that OASIS has been developing from a cybersecurity point of view, and I'll get through them here. Let me see if I can. I think one of the problems is this was developed on PowerPoint, and they're using a different. They're basically using a different application to display them, so it's a problem. They're using Keynote from Apple. Let's talk about some TCs. The ESAT, and this is a good example of building on things, like building on the work, the PKI-based authentication profiles, methodologies, and so on of FIDO. The technical committee is serving methods of authenticating electronic identities to make them more useful. And their initial project is really interesting to me and probably to you, secure QR code authentication. And their spec, which I have a copy of here, has just been under public review. It's recommending methods to have defined levels of assurance for elevating trust of an electronic identity credential based on a QR code. And there's a website that you can see there if you can capture that. It's interesting because it's an attempt to bring secure identity in a more simplified process at the outset of establishing a connection to, an online resource. You don't have to, you basically just scan the QR code, but it's a QR code that has been digitally signed. So QR code, as you probably know, is a two-dimensional version of the barcode. They have a lot more information, and so they can contain information that is not normally possible in a barcode. It's an international standard. We use them here at the conference to log in, and they're bringing a PKI-based technology to that so that you can use that. And there's a reference model. You have, obviously, the access device, the authenticator, likely embedded in your operating system, iOS or Android. You have the relying party, you have the QR code party, you have a QR code generator, and you have an authentication service. And some of these parties can be combined. It's not like they must be separated, but this is a way to illustrate the reference model. FIDO is a baseline for this fast identity and the FIDO infrastructure is relevant and can be an infrastructure used by this new process. But FIDO doesn't easily apply to a lot of use cases. For example, you might want to be able to use this type of capability at a kiosk, or you might want to use it on a Roku or an Apple TV box or something like that, and I have some examples of that. And the committee members feel that this helps make a simpler but very strong way to initiate the experience with the online service provider. So simply scanning is one thing, but as you know from scanning here at the conference, there's no security. You can scan and read a menu here at the hotel, you can scan, but there's no security involved. So the security would come from the digital signature. The private key is on the authenticator side. The public key is stored by the resource. Trusona and Hyper are companies that are actively working and have contributed technology to that, and they are here at the conference attending as well. So one advantage of this QR code approach is that it can address legacy systems, call centers, kiosks, that's how I mentioned that. It provides a common reference model that can be used by developers to integrate with their preferred underlying infrastructure for identity management and services. And it can help support and educate the industry and make that much more available to the widespread use for for use cases. I live now in Mexico, and what I told Abby Barbier from CVS Health, who's not here today, but he was one of the drivers for organizing this committee, and CVS Health uses QR codes, and I was saying that in Mexico, the Mexican government uses QR all the time for essential services, and they use PKI. So in my tax documentation, it's digitally signed. And I get not that I can use it, but I get a digital, printout of the hash, digital, the encrypted hash. So it's interesting how that's widely used, but this QR code, the QR codes there, when I had the COVID implementation, I had to, when I left the airport at Puerto Vallarta, I had to show that I had basically filled out a form saying I don't have fever and I have this and that, and I had to do it online, and you're trying to go through security, and you had to keyboard this in, and it's, you have all this, you have to show it. If the QR code, if the secure QR code had been available, it would have been much easier, instead of trying to key things into a little iPhone to show them as you go through security. So each QR code is unique to each request. It's animated and dynamic, and there's a video you can access where you can see that the shape of the QR is moving, which shows you this animation that it's actually alive, and it's a short-lived code. It's digitally signed, securely delivered to the browser. You don't have to type. There's no keylogger attacks possible. There's no PII embedded in this. This is simply a technology that allows you to authenticate yourself through the QR code. And an example that they provided is you log in on a PC using the relying party's mobile app. So the app is on the PC or on your device. I'm sorry, on the PC, and you have a mobile app. You have an existing account with the relying party. You select the option to log in via QR. A dynamic QR is served to you. It's scanned by the mobile app. A challenge is obviously required. The app is open, authenticates the web application. So it obviously minimizes man-in-the-middle attacks, keylogger type attacks, et cetera. And the relying party can validate the user is the same one as using the app. So it's a strong way to make use of a simpler way to access a resource rather than dealing with password or other options for passwordless. This is, I wish I had a shorter video to show you, but there is a video. It was produced for Authenticate Con, which was an authentication conference. And this is pretty good. It's about a 14-minute video, and it shows the operation, live operation of the use case I just described, whether you have the PC web browser and then a authenticator in your device. So again, I'm sorry this won't be posted, but if you need this, I will talk to OASIS and have this posted on the website at OASIS. Basically, they've reached the committee draft level, and it's now, I believe, finishing public review. And once if based on any input that they've resolved, any comments or recommendations, they resolve that, and then it gets published as a committee specification. So they're going to do more work after this, and I think it's a great project. Let me move into privacy and privacy engineering. This is more the space that I've been focusing on for the last many years. When I got started when I was with the government, I dealt with policy around privacy. And in those days, everything was done by the mail, or you'd go to an office, but everything was very basic and crude. And now everything is, everything's online and everything is interconnected. And why do I talk about privacy engineering? And that's a concept that I don't think has been widely adopted, but the problem is that if you look at the policy community that sets the law and that sets the rules that companies need to abide by, like the European Commission, the EU General Data Protection Regulation, or the California Privacy Act, et cetera, there's a tunnel vision of sorts in that, in my opinion, and that the focus tends to be on, well, an enterprise, basically. You know, you deal with some vendor and you deal with an online resource, and there they are, and you've got to protect the privacy. But unfortunately, or fortunately, in today's world, everything is interdependent and interconnected. So a particular resource may be using 3 different systems and subsystems and cloud providers. So how do you manage privacy in those scenarios? And that's everyday scenarios today. No, there's no one place you go to where everything is contained in one little silo, and that's just how it is. So you need to have tools that allow you to manage that intersection of interdependent applications, which is carrying personally identifiable information, and you don't have them because the focus has been on, particularly from the policy community, oh, you have a relationship with a vendor, they have your data, they have obligations, and they need to do certain things. But the data is not all resident with that vendor. It's all over the place. And it's moved on for marketing and other purposes. So we believe that privacy engineering is a viable discipline, just like engineering in the civil engineering space is a viable discipline. If you're a civil engineer and you're an architect and you're building a skyscraper, and the skyscraper is based on the ocean, then the civil engineering, the architect will work with an engineer, and that engineer will go to practitioners who are specialty engineers, who are specialties in soil, materials, specialists who understand the impact of wind on certain structures and things like that. That's all, electrical engineering and so on. All these engineering disciplines come together and they're coordinated so that when that building goes for a permit, all the essential work has been done to say this building will be safe. And these are the parameters in which we can identify that safety. We don't have that in data privacy yet, but even in, I'm sure, security, but the privacy professional needs to, or professionals, they could be specialists in identity, they could be specialists from a vendor on a particular solution around security, but they need to be brought together, and then the requirements for privacy and data protection need to be examined in the light of those disciplines. So privacy engineer must be able to understand, analyze, visualize, document, and implement technical solutions for data protection in specific use cases and targets of analysis. And that's important because if you are not examining a particular, and by use case, we really mean a target of analysis, not a generic, this is like a electric vehicle use case. We're talking about a specific instance of a use case. A particular manufacturer is building an electric vehicle and they've designed systems to communicate location, they've designed systems to monitor the characteristics of the driver, et cetera, et cetera. That is a particular instance of electric vehicle, and that would be examined by the privacy engineer. That leads to establishing the appropriate controls, and then in our model, the functional requirements that are necessary to instantiate the controls, and then you move down to the mechanisms level. Which particular operating system are we using, or which particular identity management system, or which particular DBMS is being used here. And then you need a reporting tool so you can demonstrate compliance. If you look at privacy principles, this is from ISO, but there are many, many different versions of privacy principles and privacy by design. They're very abstract. consent, purpose, legitimacy, collection limitation, data minimization, use, retention, and disclosure, accuracy and quality, openness, transparency, individual participation and access, accountability. You notice 10, information security is part of privacy. And I've been dealing with this for quite a long time. Everybody sees them as totally distinct silos of both policy and technology, and they're not. They're highly integrated because you cannot ensure, for example, number 8, access. You can't ensure individual access to data that belongs to you, sorry, I touched the mic, without having security. You can't have that ability without having the ability for an end user to have authenticate themselves and to be authorized to access the information. So these principles are great, but when you begin thinking about implementing them, you move down to the operational level. You've got to have tools to allow you to do that, and it gets very complicated very quickly. So you need to implement these privacy by design concepts, privacy principles in complex interdependent systems. And I've used this is an ancient slide from the early days of the creation of the Health Information Portability Protection Act, HIPAA, by the US government. But this was an example of a model, I think this came from, this is public source from NIST, showing that in the US healthcare system, it's a complex system, and you're dealing both with the state exchanges, messaging, standards, services, security, privacy, governance, and then you're dealing with members like, at that time it was Google Health and WebMD, emergency medical records and public health records. You're dealing with providers, a particular physician. You're dealing with payers like Blue Cross Blue Shield, Medicare, intermediaries. It's not a simple, one-stop shopping from a technology point of view or from a solution point of view from looking at privacy. I have a feeling this is so old, some of these entities may not exist anymore, but in any event, it's a good example. Another one, it's a US healthcare on-site care business process chart. All of these, or many of these business processes are supported by systems. And this is the chart of the data flows relevant to these particular on-site care scenarios, And I'm only throwing it up because it's total eye candy. It's like completely incomprehensible. But if you're trying to build a security, identity, or privacy solution across this that complies with laws, regulations, and your business objectives, then you need to really evaluate it at the use case level. What's a particular system for a particular hospital, for a particular provider, et cetera. So that's kind of where we're going with it. If you think about what I'm talking about here, privacy, security, data protection, the complexity grows by an order of magnitude as you move to the implementation level. And I think so often when I talk to my colleagues who are more the lawyers and so on, over many years I've been working on this, they see that, well, the regulation, the law requires this. And I'll come up with an example later at the very end of this, showing you how the law is great. The regulations, they want controls over personally identifiable information. They want the users to have access, et cetera. But how do you do that given those charts that I just showed you, those illustrations of actual data flows? It's not so easy as you move down to the implementation level and you have cloud providers and you have multiple systems and so on. So the implementing policies in operational systems requires some standardization, and that's what we've dealt with in our privacy standard at OASIS, the Privacy Management Reference Model and Methodology 1.0, Committee Spec 02. It's a methodology and analytic tool developed to enable the structured analysis of, quote, use cases. And I put that in quotes because you're really talking about a target of analysis. We are moving this work, the next slide talks about ISO. We're taking this specification, we've moved it into ISO, and we've some changes in terminology. And one of the pushbacks was on the term use cases, because you often think of, well, we have, as I said, we have an electric vehicle use case, or we have whatever use case, a market-based definition. But the use cases we're talking about are really specific implementation projects or specific targets of analysis that you set up a boundary around. So this would really deal with anything where personal information is used, stored, generated, processed, and erased. It deals with lifecycle, IoT, cloud. It's basically a standard that allows you to evaluate how do you implement and operationalize these requirements in a system or in an application or in a set of systems. And you show the linkages among data, the data flows, PII. You include security, and this has been a big piece of what we're doing in ISO is beefing up that interconnection with security. We want to support existing standards. It is standards neutral. It doesn't tell you or mandate that you need to do a particular solution. It simply says, do you know what solution is needed and how do you define that solution? So it really addresses the ecosystem aspect of modern applications in a way that hopefully the standard itself with some automated tools to support it, because it can get very complex very quickly, will be very helpful to people. And we've gotten very good feedback on this. It deals with stakeholders. This is sort of a wheel that shows that if you start at the top, you have business and policy mandates. And one of the most important ones is what does the business need done? And what are they willing to spend? And how much risk do they want to take with respect to the controls that they're putting into place for identity management, security, and privacy? And then you scope a use case. And then you do a detailed analysis following our task list. You develop the control requirements, both privacy and security. You define the implementation functionality that you need to implement those controls. And then if you want to move deeply into it, you can say, well, what are the mechanisms? What particular product? What solution vendor? What mechanism is in operation in my wonderful cloud storage provider where they're storing all my sensitive information? Do they do these things? What are they doing? You do a risk assessment, and it's not just a risk assessment. You think of, well, if we maintain storage of this data, what's the risk? Well, yes, there's risk, but what about the operation itself? What if there were failures of the components of this application? What if there's a denial of service attack? What if the data is not available? What if integrity is not provided for? And then you do an iterative analysis where you can re-evaluate this. The stakeholders, I want to highlight the fact that we treat end users, data subjects, or in ISO terminology, PII principles, always more complicated. Data subjects are part of this equation. The data subject, and I'm a data subject, and I have this smartphone. And when I'm working with particular vendors using the smartphone, like a resource, an Amazon or something, I'm relying on the smartphone to carry out certain functions for me. And I have some control, not a lot necessarily. I have some control of this. So the end user and the PII principle and the data subject, however you want to define them, is part of this stakeholder group who is treated in the analysis that's done by the privacy engineer. But you can see regulators, business owners, CISOs, cloud providers, everyone is a stakeholder if you look at this in a very broad way. When you look at the actual use case, or in PMRM terminology use case, or in the ISO terminology, target of analysis, you will know specific stakeholders. You will know that, we're using AWS to do this, and we're expecting AWS to handle this aspect of privacy in this way. How are they doing it? Will they tell us, or do we rely on their word or whatever? So there's a whole bunch of stuff going on here, but this is the task wheel. We also have, to make it a little bit more manageable for the engineer or for the practitioner, this is simply a labeling where we have defined service categories which embrace all of the functionality that you would expect in a particular implementation based on your business policies or security policies or privacy policies or regulations. These services are labels that help you organize the content, organize the functionality. So there's no time to get into it. We did a I did a presentation with some colleagues about 3 years ago at EIC in Munich, and we did a whole, it was a full half-day workshop on this stuff. And if you go to the OASIS Open website, you'll see a slightly younger looking, not much, guy, me, bald-headed, and the camera's right back here. And I think my bald head diffused the light or something. But anyway, there's a pretty good set of videos which goes into details on this model. We're moving this now to ISO. We started this in 2019. I'm the lead editor of the ISO IEC 27561. We now call it the POMI. The acronym is the Privacy Operationalization Model and Method for Engineering. I know it's crazy, but that's what the team came up with. It's just an acronym, and basically it's been very good because we've maintained all of the task elements, we've restructured them, we've simplified it, we have tighter integration of security and clearer definitions. We try to make this standard as self-contained as possible so you don't have to buy 3 other ISO standards. And ISO sells the standard, so if you want it to be used, you want to make it accessible, and we're trying to make it a much more usable standard. Ballot was approved in May to move to committee draft level, and we're hoping to be published in December 2023, unless there's some negative pushback from some of the national bodies, but so far it's been going well. There's a large opportunity space where standards and open projects, like I've talked about, can help solve problems. And I have one example, and then I'm going to close. I talked to a colleague, and she's a privacy expert, runs her own business, and she's been doing consulting for companies, large companies, that have to deal with access requests under the California Privacy Rights Act. And under that act, the business may require the authentication of the consumer. That's reasonable, but shall not require the consumer to create an account with the business in order to make a consumer request. So under the law, this is an example earlier where the policy people say, oh, the consumer doesn't have to have an account, but if they want to write to you, they can ask to tell you, do not give me access to my info, do not share my info, make some corrections, delete it, give me a copy of it. But they don't need to necessarily have an account. So there are also active bills. She did this great chart for me in different states that are coming up, and there's some changes and so on. But there's something called a data subject access request. And because of the law that says you don't require an account, they get them by postal mail, email, a portal, phone calls, and the companies are expected to verify identity. And the lower left block there talks about how they do that. Wide array, there's no structure to it. This is an example where she's saying in her work, if there were a standard that at least said from a trust perspective, the identity management and the authentication of these requests, you could have tiers of trust, but there must be some way to standardize this so that it's much more workable for companies who must comply. So this is one example. I asked her to provide an example where if we had a standard under development or some kind of open project, this could really be useful, and this is what she recommended. So how can you get involved in any of this? It's exciting to actually contribute to the profession. Dee Shore, she's our OASIS standards advocate if you're interested in more. d.shore@oasisopen.org. There's the website. We try to drive adoption. We're looking for more companies and experts from companies to contribute, and we hope that you'll find some of this exciting and that it will benefit you and your company and that you will be able to join us. So I want to thank you for your attention, and I know we're at the end. My timer says we have about 30 seconds left, so if you have any questions, I'd be very happy to answer them, and I'll hang around. I know there's another session, I think, in 10 or 11 minutes. So thank you very much for your attention, and I hope you have a great conference. If any questions, let me know, or come up and I can